let's recap the first derivative test, and then we'll talk about the second derivative test, which is all about concavity. So the first derivative test says, suppose you're at a critical point, but in particular one where the derivative is 0 rather than does not exist. And then if f goes from increasing to decreasing at this point, then can we say we're at a local min or max? Take a sec to think about that. Well, I could think of increasing as doing this, and decreasing as doing that. If I'm going from increasing to decreasing, then I'm at a local max, right? What's another way to say increasing or decreasing? We could say f prime is what here? This is f. F prime is positive here, and f prime is negative here. And then what would you write for a local min? Go ahead and write it out yourself here. If f goes from what? Decreasing to increasing, which would be something like this to something like that, or f prime being negative here and positive here, then we're at a local min. So that's a recap of the first derivative test. Let's think of what a second derivative test can be. What can the second derivative tell us about whether we're at a local max or a local min? So it'll start the same way. So we'll say, suppose f prime equals 0. Let c equals 0. So what do we want to say about the second derivative to say that we're at a local max, for example? So let's say if f double prime is something, then f has a local max at c. What do we have to say about the concavity of the function to have a local max? To have a local max, the function should be shaped like this, and that would be concave down. So concave down is what for the second derivative? Less than 0. And then we can say something similar. So if f double prime is positive, then the function is concave up. Then f has a local min at c. Okay, so far, any questions left in your mind? Well, here we've got negatives, here we've got positives. What else in the world is there besides negative and positives? Zeros? So what can we say if f double prime at c equals 0? That would be a candidate inflection point. That's kind of interesting. We're used to inflection points being kind of on the downhill between a min and a max, or the uphill between a min and a max. So it sounds like it wouldn't be guaranteed to be a min or a max. It sounds like it wouldn't be a min or a max. But think about this. So I'll tell you right away, it's no conclusion. Rather than saying it's definitely not a min and definitely not a max, think about these cases. X to the fourth looks like this with a very flat spot there, which was not an inflection point. F double prime is 0 there at x equals 0, but it's a local min. Is there any way it could be a local max and still have f double prime equal to 0? Well, think about negative x to the fourth. Looks like the same thing, but upside down. F double prime equals 0. So because when f double prime is equal to 0, you can have a local min, a local max, or something that's on the hill between a local min and local max. There's just nothing we can say. There's just no conclusion. It's like we don't have enough evidence. So that's the second derivative test. So if you find a critical point and want to show that it's a local min or max, you can take the second derivative and then show that that's positive at that critical point, and then that would be proving it's a local min, or if the second derivative is negative, then you found a local max.